Hello and welcome back. This is another sixth grade math video. And in this video, we're going to look at how to identify equivalent ratios. Okay, so here's our first example, and we're going to use this to talk about equivalent ratios. So equivalent ratios just means that two ratios represent the same amounts, but they use different numbers. And it's very, very similar to equivalent fractions. So that's why I like to, when I'm looking for equivalent ratios, to rewrite them in their fraction form. Because as you know, ratios can be written with a colon in between, just like this. They can be written with the word to, T-O, in between, or they can be written as fractions, even though they're still ratios. So I could rewrite 10 to 1 as 10 to 1 like this. I could also rewrite 20 to 2 as 20 to 2. So when they're in their fraction form, it's a little bit easier to kind of go back to our fractions equivalency rules and try to use those to figure out. So we have two different ways we can go about this. The first way that we can do this is we can go between 10 and 20 using either multiplication or division. So if I know what 10 times something equals 20, that would be times 2. So if I can do the same thing to the bottom and end up with this number here, if that's a true statement, then these two ratios are equivalent. So since when I multiply the top of the first one times 2, I get 20, and then on the bottom, if I do 1 times 2, I also get 2, that means that these two ratios are equivalent to each other. Now, the other way we could do this, and I'm going to erase these to show you this as well, is we can use what's called cross multiplication or cross products. The way that we do that is we multiply the two numbers across, so one numerator to one denominator. 10 times 2 is 20. And then we multiply the other pair. So 20 times 1 is 20. So if you end up with the same number when you do that, then you know your ratios are equivalent. So again, this is exactly how it would be if we had equivalent fractions. Okay, so here's our next example. We're going to look at the ratios 9 to 12 and 4 to 3 to see if they are equivalent. Now, you may be wondering, what method should I use? And the answer to that is if you can right away see how you go from one to the other using multiplication and division, I would suggest that route. But if you can't see it right away, or it doesn't look like it'll go, then try the cross products. So first step is to rewrite these in their fraction form. So I'm going to rewrite 9 to 12 as 9 to 12, looking like a fraction, and 4 to 3, also looking like a fraction. So it's not very easy to go from 9 to 4 using division. So I'm going to go ahead and test it out with cross products. So I'm going to multiply across here, 9 times 3, which equals 27. And then I'm going to come over here and multiply these two numbers. So 4 times 12 equals 48. So since I ended up with different numbers when I did the cross multiplication, that means that these two ratios are not equivalent. Okay, here's our next example. Are the ratios 5 to 10 and 2 to 4 equivalent? So again, first step would be to rewrite them in their fraction form. So 5 to 10 and 2 to 4 like this. So it's not very easy to tell how to go from 5 to 2 using division. It would end up being a decimal or a rational number, and then it would be complicated. So I'm going to go ahead and try the cross product way. I'm going to go ahead and multiply 5 times 4, which is 20. And then I'm going to multiply 2 times 10, which is also 20. So even though at first, when I looked at it, I couldn't tell whether they were equivalent or not because I didn't have a number I could multiply or divide the top and the bottom by, but it turns out they are equivalent because when I did cross multiplication, I got the same number. So the ratios 5 and 20, sorry, the ratios 5 to 10 and 2 to 4 are equivalent. Okay, here's our next example. We need to select all the ratios from the ratios given on the left to see if they are equivalent to 16 to 8. So the only way to really do this is to just take one choice at a time and see if they are equivalent. So I'm going to go ahead and rewrite 16 to 8 in its fraction form right here. And then I'm going to start the first one, 14 to 4. So it's not very easy to tell right away how to go from 16 to 14 using either multiplication or division. Or if I did, it would have to be some kind of fraction or decimal. So instead, I will use the cross multiplication way. First, I'll start by multiplying 16 times 4. So 16 times 4 ends up being 64. And then I'm going to end up multiplying 14 times 8, which gives me 112. So since these are different numbers, I know that these two ratios are not equivalent. So I'm going to cross off this choice right here. Now I'm going to erase that choice, leave the 16 to 8 over there, and set it up for 4 to 1. Okay, now this one's a little bit easier because I know that if I go from 16 to 4, that 16 divided by 4 gives me 4. But if I divide 8 by 4, I should get 2, not 1. So that tells me that this one is also not equivalent to 16 to 8. So that means it's got to be, by process of elimination, it's got to be C. But let's prove it. Let me delete all this. Okay, so I'm going to set it up with 6 to 3 here. And again, kind of hard to tell how to go from 16 to 6 using division. So I'll use cross multiplication. 16 times 3 is equal to 48. And then 6 times 8 is also 48. So that does prove that C is the option here. Okay, here is our last example for today's video. We're going to select all the ratios from the list on the left that are equivalent to 16 to 2. Okay, so let's go ahead and put 16 to 2 here in its fraction form. And over here, I'll put the first choice, which is 26 to 3. Again, I can't really see how to go from 16 to 26 using multiplication, so I'm going to do the cross multiplication method. I'm going to start by doing 16 times 3, which gives me 48. And then I'm going to go over to the other side and do 26 times 2, which gives me 52. So I did not get the same number when I did that. What that means is 26 to 3 is not equivalent to 16 to 2. So let me go ahead and erase that, and I'll try the second option. Second option is 48 to 6. Okay, now this one, can't really tell how to go to 16 to 48, but I can definitely tell that if I did 2 times 3, that would give me 6. So what I'm going to do is test out what 16 times 3 is. Okay, so that means 16 times 3 is 48. It's exactly 48. So that means this one is equivalent. Okay, I'm going to go ahead and take that down. And I do have to check the last one because there could be more than one option here. So I'm going to put 9 to 1 up here. Okay, again, can't really tell how to go from, well, I mean, I could do 2 divided by 2 gives me 1. That's true. I didn't even look at that. Okay, then if I do 16 divided by 2, I should end up with 8, not 9. So that means that that one is not equivalent. So the only one from this list would be 48 to 6. That is equivalent to 16 to 2. All right, you guys, thank you so much for joining me today. I hope to see you in another video soon.